Hello, everyone. I'm Simon Turner, founder and principal of Building Cognition, a board advisor to SafeTraces, and a long-term veteran of the indoor air quality field. I'd like to welcome you to a special edition of our Healthy Air podcast, where we're excited to welcome three distinguished guests for a panel discussion on the recent launch of UL's Verified Ventilation and Filtration verification mark, powered by SafeTraces technology. It's the first rating and assessment program verifying real-world ventilation and filtration for aerosol removal efficiency in the built environment. So our first panelist is Sean McCrady, Director, Assets and Sustainability, Real Estate and Properties at UL, the Global Science Safety Leader. Sean provides expertise, technical development, research and development, and client support. With over 23 years of industry experience, Sean delivers on in-depth knowledge of the needs and concerns of building owners and managers to develop efficient, cost-effective solutions to indoor environmental issues. Our second panelist will be Dr. Elliott Horner. He's lead scientist at UL Environment. Elliott has written numerous peer-reviewed research papers and book chapters and serves on committees for ASTM and ASHRAE. He's a member of the American Society of Microbiology and the Mycological Society of America, and is a fellow of the American Academy of Allergy. Our third panelist is Erik Malmstrom, CEO of SafeTraces, a safety technology leader focused on indoor air quality and ventilation safety. SafeTraces has developed the first commercial solution for field verifying ventilation and filtration performance for aerosol removal efficiency. So, Erik, I'd like to kick off this discussion, if I may, with you. Could you give us a high-level overview of the recently launched verification mark? What is it exactly, and how does it work?
Sure. Thanks so much, Simon, and great to be here. And thanks so much to Elliott and Sean for joining. So we're really excited about this program. As you mentioned, it is the first program where you can go into a field environment, a real world building, and actually test and verify how well the ventilation and filtration systems are removing aerosols out of the air. The way it works is that the program has two components. The first is a comprehensive desktop audit based on the building data, the building design, the HVAC system, and other material information related to how the building is ventilating and filtering air. And then in addition to that, and really a critical differentiation of this program, is the second component, which is field verifying this performance through using an aerosol-based test methodology, our VariDart platform, which consists of DNA-tagged tracer particles that simulate respiratory emissions, and where we can actually go in and prove out the numbers on paper from the desktop audit in the field. The way this works is that SafeTraces and UL will work with a building owner and operator to just determine within their building, the areas that are considered high density, where we believe there's more risk and where we're really focused on. And then we'll go out and kind of scope out a testing plan and test specific areas against a performance target. To date, there has not been a clear performance target that's been established by regulatory bodies and standards bodies. However, infectious disease science and other public health organizations have given us some clues as to what would be considered an adequate level of aerosol removal. And so we've come up with our metric based on that. And really the value of this program comes down to having building owners and operators be able to use an independent science-based verification program to test their building and then communicate that the building is achieving a certain standard to the occupants of that building. As polling data shows across the market right now, many people in the public don't have trust in building safety. And this is after 2 years of the pandemic. In some polls, it's showing 90% of the public don't have trust that the places and buildings that they're going back into are safe. So this program is really focused on having a way of communicating health, wellness, and safety via this program. And we're really excited. We think there's huge potential and need for this right now.
Thank you, Erik. That's very interesting. Elliott, I'm going to direct a few questions to you just for our audience to get a better technical understanding of exactly how this might work. If you would unpack some elements of the verification mark for us. So let me ask you first, why is it focused specifically on ventilation and filtration?
Well, that really is key to the whole process, Simon. And there are two well-established methods for removing aerosols in an indoor space. If the aerosol has an indoor source, then outdoor air is a diluent, lowering the concentration of the aerosol. And regardless of where the source of the aerosol is, filtration, either local or inside an HVAC system, will capture aerosol particles from the air. In combination, ventilation and filtration, these work together to really increase the aerosol removal, which is what we're aiming for.
So, Elliott, why is it focused on aerosols in the first place?
Well, the intent of the program is to provide assurance that we can reoccupy our buildings with minimal managed risk of further contagion. We're all ready to get past that. The COVID virus rides around on aerosol particles. So if you get the aerosol particles, you get the virus out, or at least get it down to manageable levels.
So my understanding is that this technology is using as a benchmark a 99% removal rate as like a verification benchmark, if you like. Why 99%? Why is it focused on that number?
99% is half of what we're aiming for. The other half is the effective air change rate, which is the ventilation rate plus the internal filtration rate. Together, the 99% reduction in the test and the elevated air change rate are about equivalent to walking into a building with a mask on.
Well, I think that's key. If you can help our audience understand that it's like walking into a building with a mask on if you're down to that kind of level of reduction. I also understand that this verification mark tends to focus on high density areas. And maybe you could explain to us, Elliott, why that's so important.
Sure. Well, first of all, the high density areas are defined as reasonably small air spaces with 2 or more people in it. So it's not a football stadium by any means. The program seeks to focus on those areas because that's where the highest risk of transmission is, where you've got multiple people fairly close together for more than just a few minutes. So the testing the aerosol in those areas will give the biggest bang for the buck. Also, assuming the ventilation filtration strategy for those areas is also deployed throughout the facility, which is part of the desktop review, then the aerosol reduction benefits in those other areas that are not tested should be similar. But the extra testing would add cost, but not really much additional value. So it's the reason we're focusing on those areas, but by extension, it should apply to other areas within the defined space.
Well, that makes sense, Elliott. I know throughout my career in the field of indoor air quality, one of the things that has vexed me over those years is not much of a focus or access to regulations and standards that really address ventilation and filtration performance, generally regarding aerosols and airborne pathogen removals. There's really not been a lot of regulation and legal standards that could be applied. Maybe that's changed. Maybe, Elliott, you can tell us a little bit about the landscape regarding regulations and standards for aerosol and airborne pathogen ventilation and filtration in this day and age.
Well, Simon, I think we've certainly got a lot more attention that's being focused on indoor air quality in general, aerosols in particular, and we may see some of those changes that you referred to. However, I don't think that we're there yet. So far as I know, the only standards and guidelines for control of airborne pathogens are for hospitals. As for aerosols more generally, some jurisdictions have requirements for a certain grade of filter in certain types of buildings, and there are guidelines for how big of a room an air cleaner can handle. None of these address verification in the real world, rather than in a test facility. So I think we've still got some work to do there.
Okay, well, that's certainly been my experience too. So, Sean, I have a question for you. There's been a whole range of different verification and performance testing programs out there in the world of commercial real estate, and there has been for a couple of decades now. But how are existing programs out there really addressing these ventilation and filtration performance standards? In other words, are the existing verification programs already addressing this risk area? And if not, why not? And if they are, how are they doing that?
Yeah, it's a good question. And I think that, I think while some of the existing building verification and certification rating systems and programs and what have you, they include even our own, right? Even the UL Verified Healthy Building program. You're looking closely at filtration and ventilation, but it's in a much more sort of general way, right? Or generic way, I guess you could say, and much more of a prescriptive way. All right. And I think just by definition, when you talk about what filtration and ventilation is, of course, this does include aerosol removal, by definition, but again, it's more indirect. And I'll kind of explain that a little bit in a second, but here are some examples, right? A lot of these programs have prescriptive requirements, right? You need to have a certain MERV rating on your filter, or there might be a sort of a maintenance and management requirement that these things are observed closely and managed properly, or when it comes to ventilation, making sure from a visual inspection respect that fresh air dampers aren't closing, or maybe that ASHRAE 62 minimum outdoor air requirements are being met, or even CO2 testing, right? That's often been a kind of a surrogate for how well we're ventilating spaces. And of course, there's some things there in terms of being contingent on people actually breathing out CO2, so it's not perfect by any stretch. But when you think about it, I mean, just common sense here, right? There's no better way to see if these prescriptive things, if these surrogate things, and these sort of indirect things that you're doing are working in terms of aerosol and airborne pathogen removal than actually releasing aerosols and seeing what the heck happens, right? That's all these things that I was just talking about, these prescriptive things, these kind of surrogate things, they all have a lot of merit, right? But I think this final piece that is really new to the industry, right? I think this is kind of that icing on the cake of seeing what is actually happening. Are the things that we're doing actually working? It's pretty cool stuff.
Very good. Yeah, that's interesting. So my next question is to you, Erik. I'm interested in you giving us a little background about technology in this field. What role is technology in this day and age playing in enabling effective field measurement and verification? And how's it evolved recently in that regard?
So technology is a huge part of this program and a huge part of the story of why we are able to do what we're doing now through this program. Traditionally, to test ventilation and filtration in the field, you have two kind of best-in-class approaches. For ventilation, tracer gas, sulfur hexafluoride or carbon dioxide are two main tracer gases, which you would use to go into a building and determine the air change rate. And that would give you a number. A tracer gas has one big drawback as it relates to infectious aerosols and things like COVID and influenza, which is a gas goes straight through filters. So you're getting half of the story. Ventilation, you're able to measure, but you're not able to measure the filtration impact of removing aerosol particles. So then you say, well, how do you measure filtration and what's a best-in-class kind of a test approach for that? And there, many would consider solid particle challenge tests, where you're putting in solid particles to challenge the filter and see how much is being removed. That's what's being done right now, to the extent that things are being done at all in the field. And it's the reverse story of tracer gas. You're testing the filtration efficacy, but you're not testing the ventilation. So really what you want to do is to determine how the ventilation and the filtration are removing aerosol particles. And you can't do that. You have to put these two things together. The other big drawback of these two approaches is that the data is portrayed in a way that is often geared towards scientists and other technical people. And really, air is something that many people, including myself, best understand visually. How is it moving around? Where is it going? And how efficiently are the systems removing it from the air? And really, the best tool that we have at our disposal for visualizing airflow is a computer-based modeling program called computational fluid dynamic modeling, which is great at showing how air moves. It's colorful, it's visual, it's 3D, but it's also a model, and it's not real world, and it often relies on assumptions that are not always based on ground truth. So to put all those things together, what you really want is a technology that can test ventilation and filtration in one test, and then visually convey the information to tell you what's going on, to then ultimately be useful so people can make safety, financial decisions with that data. Well, that's what SafeTraces is developed. Our Varied Art platform is using DNA-tagged aerosol tracers that safely simulate respiratory emissions of sick people. So you can release them in public spaces. The materials are federally or FDA generally recognized as safe. So it's basically water and then a food grade DNA that's non-native to the environment. And you can release those tracers, and the DNA tag allows us to sample throughout the space with air samplers and see how things are moving around, and basically then map out airflow, where there may be hot spots, and then importantly, how the ventilation filtration system is removing this particulate from the air. And then also how you can optimize your systems, because it's not just health and safety that matters. That's obviously most important, but you also care about how you're spending your money, whether it's the energy implications of your strategy, where you're putting capital within a building or within a portfolio, the carbon emissions that are a result of your strategy. And so all this data ultimately then becomes something that is filling a huge vacuum. There's never been a measurable, verifiable way to test the systems on this dimension before. And that's what our technology does and why it's so groundbreaking. So it actually, instead of using kind of other general approaches, as Sean mentioned, or making assumptions based on kind of theory, or using limited applied tools, it kind of puts everything together in a very powerful way that then gives you very high quality field data, which then can sharpen the kind of accuracy of what's going on, and then ultimately make spaces safer and better performing.
Yeah, I think there's a good segue there, because essentially what you're saying, Erik, is that this has moved out of the lab. It's moved out of the computer. It's no longer we no longer require CFD modeling to do this kind of stuff. We no longer require this stuff to be done in theory in chambers. Which brings me, Elliott, to a question for you, really, about taking it from the lab or computer environment into the real world. Try to give us a general sense about how different types of everyday buildings, real buildings, schools, offices, industrial, how are they positioned to meet the standards that you can assess in this program with this technology?
Well, it's not a standard yet. We certainly would like to see it move in that direction. But Simon, we're in uncharted territory. The existing design criteria for buildings typically, or perhaps always, claim to be for normal conditions rather than for unusual conditions. There's been a lot of discussion lately in standard circles about why buildings can't respond appropriately to the wildfire smoke episodes. And the response is, well, that's an unusual event. We got a lot of unusual events these days, particularly here in the last 2 years. But if you only build for normal conditions, you have no cushion for unusual events. That said, there are buildings that are and always have been above and beyond the minimum requirement. I anticipate those buildings may not need extensive upgrade. Buildings built, operated only to conform to minimal allowable criteria, those buildings are probably going to need some more modifications and investment to be able to meet the criteria in this verification mark.
Okay. All right. Let's move in the time we have available on from the technical to the commercial. And Sean, I'd like to bring this back to you to really get an understanding from you, if we may, about who the target customer for this performance mark might be, and what's your value proposition to them?
Yeah, sure. Look, I think anybody that has employees, that has patients, that has customers or tenants or what have you, I think, where there's any concern, and I don't know who doesn't have concern about health and safety these days, right? And also concern about liability, right? That's a big part of this as well, and being able to kind of show a good faith effort and protect from liability. And look, we all know in this meeting, in our industry and everything, and hopefully a lot of other people know as well, that you can't move the risk needle to zero. There's always going to be risk, right? But the name of the game is really doing what you can to reduce that risk. And that's really the real objective, and it's what it's all about. So I think there are a lot of different vertical or industry segments that could benefit from something like this. I think probably the most direct benefit would be the corporates out there, right? Where there's a direct sort of benefit from having healthier, safer, more productive employees. Of course, healthcare is another one where, like you've got immunocompromised people. How could this not be uber important, right? But I want to go back to what came up earlier that Doc Horner was talking about, which is it's really kind of when you talk about the value proposition, if just the very fact that you can essentially achieve an environment indoors that essentially is the same of having a mask on with no mask on, that's huge, right? I mean, that is really that's all the value proposition you need. And if there's anybody who doesn't think there's value in that, I think they need a talking to, because with everything we've just gone through, and it's not, look, I know COVID is starting to feel like it's going in the rear view a bit, but the next thing is going to come along, and there's plenty of other communicable diseases out there that this is impactful to. So I would ask, who is this not for, right? I think that's one way to look at it. Hopefully that answers your question.
Yeah, I mean, it begs the question. I mean, what is this mark's value proposition beyond health and wellness, and certainly beyond the COVID-19 pandemic? What are the applications beyond COVID-19, do you think?
Yeah, well, I think part of it is about, we always talk about finding the sweet spot, right? It's not, when we think about sustainability in general, and we think about energy and carbon footprint and all that, there's always a sweet spot. And so I think that using something like this to make data-driven, thoughtful decisions on, how to economically address ventilation and filtration and aerosol reduction, and consider energy consumption at the same time, that's a big deal, right? We always talk about how the biggest ROI in buildings, the thing that was missed for so long, is that it's people. It's a people above all else, but that doesn't mean we want to ignore the other stuff, right? The energy piece is still really important with everything going on to the planet, and just with our energy bills and everything else. It's really important. So I think it's finding that sweet spot and having just that much more really good, really sort of tangible data that you can make smart decisions. And look, in terms of going beyond COVID, I think we can all agree COVID changed the game, right? And it's not because aerosol transmission wasn't important before, but in a very lasting way. I mean, I think the big difference is awareness. Everybody knows what MERV is now. Nobody knew what MERV was before. So the awareness is raised, the expectations have raised. we're not going back to the way we were before. Everybody's concerned about this stuff. It's top of mind. So really the thing that I would say is COVID's the elephant in the room, but there are a lot of communicable diseases that if you're managing this stuff, you will have a very big impact on the building, not to mention all the stuff on indoor air quality in general that's come out of, from Joe Allen and the Harvard School of Public Health that I know that you've done a lot of research on, Simon. I think we all have, but, having better ventilation, having better filtration, it's not just about people's health and wellness. It's about their productivity and cognitive function and all of that. So, it goes well beyond COVID. And I think most people can probably see that now.
Right. Yeah. Yeah. I'd like just, personally to echo that the ventilation aspect in particular is where it's at when it comes to people performing well in buildings, irrespective of whether we're managing infectious aerosols. Absolutely. So,
Simon, can I just add?
Yes.
I just want to add to both your and Sean's comments. At the beginning of the pandemic back in 2020, I vividly remember a discussion with a prominent indoor air quality expert who was exasperated and said, "We need an effing number." And what he was talking about was that we need a measurable, verifiable way in a non-healthcare building to say, here's the bar and the target that we're shooting at. Because once you have that, then you bring some clarity to the market.
Yep.
And we have not had that for 2 years now and still waiting. We have not had clarity on that number. We're still waiting for that number. And by not having that number, that you have just very uneven performance and confusion across the market. It's such that it roils things for the public, who it drives the lack of trust and confidence. And for the building owner and operator, it's frustrating because things keep changing and they don't know where they should be. And so sometimes there's a cynical view that building owners or operators don't want to do the right thing. My experience has been the opposite. They want to know, what should I be doing? And then they want to go and achieve it. And they want certainty and clarity on that. This is our attempt to do that. And once you have clarity on that, not only can you help improve health and safety and wellness, and reduce, otherwise preventable infections, but you can then say, okay, well, and how can I achieve that target in the most cost-effective way? Because there are lots of ways to achieve the target, and they're not all the same. And across buildings, those are going to change. And additionally, on the energy side, given how important that is to the broader net zero decarbonization angle on buildings, ventilation and filtration can use a lot of energy if you're not careful. And there are much more energy efficient ways of providing ventilation and filtration than others. And so by having a target, you kind of lock all of those things and you address the fundamental mistrust problem that exists right now. And I think it's huge. It's been one of the big missing things for the past couple of years.
Yeah, to add to that even further, Erik, I mean, to be clear too, you're right. I think that's a really good point. And man, wouldn't it have been great to have had the insight 2 years ago? Think about how much of an impact it could make, but it doesn't mean it's too late. I mean, it's certainly not too late. We've kind of learned the hard way collectively that there's a real gap and a real need. So hopefully we're filling that. We're better prepared next time.
Right.
Incredibly timely right now, too, in that many across the country, many states and localities are removing mask mandates. And so there is this question of, are we ready for that? And so this becomes, even though we're 2 years too late in some respects, now is as good a time as any, because we're about to begin a huge wave of bringing people back into buildings.
Right. Well, that's been very interesting. And it remains for me to ask you, Erik, for those people listening to this podcast who have decided that it's about time they got their effing number for their building, how can they follow up to learn more and pursue this verification mark?
Sure. So first off, I would encourage people to go to SafeTraces.com, where this will be on our homepage. You can link to more information. Secondly, emailing us at info@safetraces.com is another way to get directly in touch with a representative to get more information. And then third, there's also going to be information available on UL's website, and Sean can say a bit more on that. But basically online, going to either company's website, you can navigate yourself to speak with a representative, get basic program information, and basically dig into this more to see if it's relevant. We think that it will be for many, and beyond the program details itself, the cost, how it actually works, the timelines, all of that information will be provided.
Very good. Anyone want to add anything else before we close out? Well, thank you. Thank you so much for listening, everyone. And we look forward to working with you in the future.